Three equal vectors separated by 120 degrees can form a balanced pattern in a plane, and that pattern naturally points to a fourth direction that is not drawn in the plane. The main idea is that symmetry in 2 dimensions can determine a perpendicular direction in 3 dimensions, so the explanation follows how the shared length, the equal angles, and the cross product work together to reveal that implied direction. The 3 given vectors are arrows in 3-dimensional space, but their tips lie in one flat plane, so their balanced arrangement can be studied as a 2-dimensional shape sitting inside 3 dimensions. Vector magnitude means the length of a vector, and magnitude parity means the 3 vectors have the same length, so none of the arrows is stronger or longer than the others. When the 3 magnitudes are equal, the center of the pattern acts like a point of balance, because each vector contributes the same amount of length away from that center. Angular symmetry means the angle between each pair of neighboring vectors is the same, and in this case, each separation is 120 degrees. 120 degrees is exactly 1/3 of a full turn, so the 3 vectors divide the plane evenly into 3 matching sectors. Because the lengths match and the angles are evenly spaced, the 3 vectors form a symmetric planar system whose in-plane poles cancel rather than favoring one direction inside the plane. An orthogonal vector is a vector that meets another direction at a right angle. So a vector orthogonal to this whole plane must be perpendicular to every direction lying in that plane. The direction perpendicular to a plane is called a normal direction, and a flat plane in 3-dimensional space has 2 opposite normal directions along the same line. The cross product is an operation that takes 2 non-parallel vectors in 3-dimensional space and produces a new vector perpendicular to both of them. Since 2 of the 120-degree vectors already lie in the same plane and are not parallel, their cross product points along the normal line of the plane. The third vector lies in that same plane, so the normal vector produced from the first 2 vectors is also perpendicular to the third vector. This means the cross product does not merely give a direction outside one pair of vectors, but gives the single axis that is orthogonal to the entire 3-vector plane. The balanced 120-degree arrangement makes that normal direction feel implied because the system has no preferred direction within the plane and therefore its unique outside direction is the perpendicular axis. The implied fourth is this non-zero normal vector, generated by the orthogonal relationship between the symmetric planar vectors and the 3-dimensional space around them. Its sign depends on the order used in the cross product, because reversing the order points the normal in the opposite direction along the same axis. So, to find the implied fourth, identify the common plane of the 3 equal 120-degree vectors, take the cross product of any 2 non-parallel vectors from that plane, and use the resulting perpendicular normal as the fourth direction.